So now we're going to take a look at the graph of a secant function. So look at y equals 3 times the secant of 2x minus pi. There are a couple different ways that you can graph this. I'm going to use a method very similar to how we graphed the sine and cosine graphs because I prefer it. Alex will probably teach you a different way. You can use whatever method makes the most sense to you on the exams. So the way I like to do this is to think about the graph of secant as the reciprocal of the cosine. Okay, so we can think about 3 times the secant of 2x minus pi as being 3 times 1 over the cosine of 2x minus pi. Okay, so what do we know about the cosine of 2x minus pi? Okay, so the first thing we know is that the period is going to be pi. Okay. Since we have a 2 times x, the period is going to be 2 pi divided by 2 is pi. And then a quarter of our period is going to be pi over 4. Okay, so we think about where our quarter points would be. It's going to start at our phase shift, which is going to be pi divided by 2. So remember, when we have a bx minus c inside the sine or cosine, the first quarter point will be at the phase shift, which is c divided by b, in this case pi divided by 2. The next one will occur after 1/4 of the period. So that's going to be at pi over 2 plus pi over 4 is 3 pi over 4. The next one is going to occur after another quarter of our period. So that's going to be at x equals pi. Then we'll have one at 5 pi over 4. And then after one full period, pi over 2 plus pi is 3 pi over 2. Okay, so we're going to use those 5 x coordinates to do our secant graph. So we're going to have x equals pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. Okay, and then in the next column, we're going to look at our cosine. So we would have our values for cosine of 2x minus pi. Okay, and then finally our values of 3 times 1 over the cosine of 2x minus pi. And that's going to be our y. Okay, so we have these cosine values as an intermediate point, basically. And then we're going to take 3 times the reciprocal of the second column to get our actual y values. And that's our third column. And we'll plot those. Okay, so to start out, when x is pi over 2, 2x will be pi. So we're going to have the cosine of 0 is 1. And I'm just going to go down the second column here to start. When x is 3 pi over 4, 2x will be 3 pi over 2 minus pi is pi over 2. So we're going to have cosine of pi over 2, which is 0. When x is pi, 2x is 2 pi, minus pi is 1 pi. So I'll have cosine pi is negative 1. When x is 5 pi over 4, 2x will be 5 pi over 2. We subtract pi, we get 3 pi over 2. So we get cosine 3 pi over 2 is 0. And then finally, when x is 3 pi over 2, 2x will be 3 pi. 3 pi minus pi is 2 pi. So we have cosine of 2 pi is back to 1. Okay, so I'll remind you, this is what we did when we were doing sine and cosine graphs. And if you get your quarter points correct, you should end up with 0, pi over 2 pi, 3 pi over 2, 2 pi that you're taking the sine or cosine of. So that's how I was able to work through this so quickly, because I knew what these values in the parentheses should end up being because I chose my quarter points correctly. Okay, so now what we're going to do is take these values in the second column, take their reciprocals, that'll give us the secant, and then we multiply by 3. So to start out, we're going to have 3 times the reciprocal of 1 is 3. Okay, so we have a point at x equals pi over 2, y equals 3. For our next point, cosine is equal to 0. So to get the secant, we'd have to try to take the reciprocal of 0. So the secant is going to be undefined. Okay, so when x is 3 pi over 4, we don't get a y value. Secant is undefined. We're going to have a vertical asymptote there. When x is pi, the cosine was -1. So our y value will be 3 times 1 over -1 is -3. When x is 5 pi over 4, the cosine was 0. So again, the y value will be undefined. There's going to be another vertical asymptote because we'd have to divide by 0 to get the secant. And finally, when x was 3 pi over 2, cosine was 1. So 3 times the secant is going to be 3. All right, so those are our points and our asymptotes. Okay, so just like when we were graphing a tangent or a cotangent, we're not going to have 5 points here. We're going to have some points and we're going to have some asymptotes. Okay, so we're going to start at x equals pi over 2. It's going to be the beginning of our period. End is going to be at x equals 3 pi over 2. And we have the 3 values in between. 3 pi over 4, pi, and 5 pi over 4. Okay, and then when x is pi over 2, y is equal to 3. So we have a point at pi over 2 comma 3. When x is 3 pi over 4, we have a vertical asymptote. When x is pi, y is -3. So we're going to have a point at x equals pi, y equals -3. When x is 5 pi over 4, y is undefined. We have another vertical asymptote. Okay, and finally, when x is 3 pi over 2, y is going to be 3 again. Okay, so we take our points and our asymptotes, and then we fill in the graph of our secant. Okay, so remember what this looks like. When we have the upper point, it's going to be the bottom of a bowl. So we're going to have this relative minimum as our function values go up to infinity. And if you wanted to, you could, go another pi over 4 units. So remember, a quarter of our period is pi over 4. So if we trace back another pi over 4, we're going to hit the next vertical asymptote. That's optional, but that kind of helps you figure out where the left-hand side of this graph is. Okay, and then we have this point at x equals pi. This is the lower of the points. So remember, that's our relative maximum. That's going to be the top of our hill. And then our function graph will go down to -infinity. And then up here we have another higher point. So it's going to be another relative minimum. And again, we don't have this vertical asymptote here, but we can figure out where it is because each of these ticks are pi over 4 units away from each other. So here, if we take 3 pi over 2, that's 6 pi over 4. We add another pi over 4, we get 7 pi over 4. Then if we wanted to, we could do some more vertical asymptotes. But when we do a secant or cosecant graph, we get this alternation between vertical asymptote point, vertical asymptote point, vertical asymptote point, vertical asymptote point, etc., etc. And our points just alternate between high, low, and so on. If this were a cosecant, this would be very similar, but now we would start out with an asymptote instead of a point, because remember, cosecant is the reciprocal of sine, and the sine values start out at 0 instead of 1. So the first thing you'll get is an asymptote, and you'll go asymptote, point, asymptote, as opposed to point, asymptote, point, but it's the same idea.